In this video, we will be learning how to solve rational equations. So before we begin solving rational equations, we need to talk about what a rational equation will look like. So a rational equation is defined as an equation involving one or more rational expressions. So, for example, we might see something like x plus 4 over 7 equals x minus 5 over 12. This is an example of a rational equation because it has a rational expression on each side of it. Now what we also might see is something slightly more complicated looking, like say 5 over x plus 2 minus 7x over x plus 1 equals 12 over x. So notice that we have three rational expressions packed into this, and we'd have to use a variety of rational expression simplifying strategies in order to actually solve this equation. But all of these are going to be equation types that we'll be able to solve by the end of this lesson. So when solving rational expressions, we actually have two different methods that we can use, and which method we use kind of depends on the situation that we are given to start with. So cross multiplication is a strategy that you're probably already familiar with, and we can use it whenever we have a situation where we have a fraction is equal to a fraction. Now this will only work when you have a single fraction equal to another single fraction, so it's pretty limited, but when you do have fraction equals fraction, it's pretty convenient because we're able to just use this quick little trick and solve and move forward. So cross multiplication, when we use this strategy, we take the numerator of the first fraction and we multiply it by the denominator of the second. And then we set that equal to the numerator of the second fraction multiplied by the denominator of the first fraction. So here we're going to have 3x plus 2 times a negative 2x. So from here, now that we've used cross multiplication, all we need to do is solve this. And to do that, we're going to start by getting rid of the parentheses so we can see what we're working with. So we have 2x squared plus 16x minus 8x minus 64 is equal to, I can distribute this to both, negative 6x squared minus 4x. So now from here, what I notice is that my highest power in this equation is an x squared, and I have a couple of them. And that's telling me that I'll probably need to use my quadratic solving strategies, so factoring, square roots, or the quadratic formula, because I have a quadratic in front of me with that x squared involved in the problem. So I'm going to start by getting all of the terms on the same side of the equation. So I'm going to add 6x squared to each side, add 4x to each side. So as I do that, I can start combining all of these like terms together. So I have 8x squared. I then have all of these items to add together. So I have 16 minus 8, which is 8, plus 4, which is 12. So I have plus 12x, and then I have minus 64 is equal to 0. Now because I have some large numbers here, I'm going to use the quadratic formula because that will just be the easiest and most consistent strategy that I can use here. So if I use the quadratic formula, I have x equals negative b plus or minus the square root of b squared minus 4 times 8 times c all over 2 times a. And then if I start simplifying underneath that square root there, I end up with 12 squared minus 4 times 8 times negative 64, which is 2,192 over 16. Now for the sake of this problem, I'm okay if you get the decimal answers and you round. So if we square root 2192, we end up with negative 12 plus or minus 46.82 over 16. We then split it into a positive and negative version, so I have negative 12 plus 46.82 over 16, or I have negative 12 minus 46.82 over 16. So if I take both of those, if I add the numerators and then divide by 16, I end up with one value that is 2.18, and then I end up with a second value of negative 3.68. So these are my two possible values for x that if I take them and I plug them back into my original equation, they will make that original equation true. Now the second quadratic solving method that we can use involves getting common denominators. And if we can get common denominators across all of the rational expressions in our rational equation, we can essentially eliminate the denominators and just focus on the numerators. So that's what we're going to use here. Now the reason we cannot use the cross multiplication strategy here is because we have more than just a fraction equals a fraction. If you look closely, we have a plus sign between two fractions on one side, and there's really no way to turn this into a fraction equals a fraction unless we do some changing to the problem getting common denominators. So that's what we're going to do here. So what I notice when I look at this problem is that we are close to having common denominators here. When I look closely at this, I notice that these two already share a 2x. So that means that this middle fraction here needs to be multiplied by 2x to get there. And then I also notice that there's only one thing besides the 2x, and that's the x minus 3. So that tells me that this needs to be multiplied by x minus 3, and this needs to be multiplied by x minus 3, as well as this fraction over here. So if I perform those multiplications, I will have a common denominator of 2x times x minus 3. So let's go ahead and perform those calculations. So in this first fraction here, I'm going to distribute the 8 out. So I end up with 8x minus 24 over 2x times x minus 3. Then plus, if I distribute this 2x out, I end up with 2x squared minus 4x over 2x times x minus 3 is equal to, this one's going to take a little bit more, so I have to do 3x times x and 3x times negative 3, so that's going to be 3x squared minus 9x, and then this becomes plus 2x minus 6 all over 2x times x minus 3. Now, because I have these common denominators, what I can essentially do here is I can essentially eliminate them because every single term has that common denominator, and I can change this into 8x minus 24 plus 2x squared minus 4x is equal to 3x squared minus 9x plus 2x minus 6. So now I have an equation that I can work with a little bit easier because I'm no longer working with fractions. So using the common denominators trick essentially allows me to eliminate the fractions because they all have the same denominator. So we're just going to focus on the fact that the two numerators being added need to equal that third numerator. Now here I'm going to simplify this a little bit by combining some like terms and writing these in descending order. So here I have 2x squared plus 4x minus 24 on the left-hand side. I combined those together and then just rearranged them. And then here I have 3x squared minus 7x minus 6 because these combine together. So from here I can see that this is probably a quadratic because I have all of the x squareds in the problem. So I'm going to get everything together on the same side of the problem. So I'm going to subtract the 2x squared over the 4x and then add the 24. And so here I'm going to subtract the 2x squared over minus the 4x and then again add the 24. So this becomes 0 is equal to 1x squared minus 11x, and then negative 16 or negative 6 plus 24 is a positive 18. So from here we are going to solve this quadratic. Now, we have a couple of options here because, well, yes, we can use the quadratic formula. That will always work. What I notice, this is a pretty simple quadratic. Here we have A is equal to 1, B is equal to -11, and C is equal to 18. So while we can use the quadratic formula here, what I'm also noticing is that this is pretty simple and easy to factor. So I could use my factoring strategies instead, because with an A value of 1, I need two numbers that multiply to 18 and add to -11, and that would leave me with -9 and -2. So instead of using the quadratic formula here, which again you can use, I'm going to use my factoring strategies and rewrite this as x minus 9 times x minus 2, and then I can just set each little mini equation equal to 0 because of the zero product property and solve. So I find that my two x values that make this equation true are x is equal to 9 and x is equal to 2. And if I were to take those original values, or those values, and put them back into this original equation up here, they would make this original equation true. So let's try one more example here with the common denominators. So here I notice that I apparently seem to have three different denominators, but when I take a look at the x squared plus 2x minus 35, I know that I can factor that further by looking at what two numbers multiply to be -35 and add to be 2. When I think about those numbers, I note that x squared plus 2x minus 35 can be factored into x plus 7 times x minus 5. So I'm going to rewrite that there. Now from here, I know that I need to get common denominators if I want to be able to add these fractions together on the left and then set them equal to what is on the right. And what I notice here is that by having x plus 7 and x minus 5 in my denominator on the right-hand side of the equation, I'm actually accounting for both values on the left. So what I can do here is I can make this the common denominator that I need. So if I multiply this first expression here by the x plus 7, that will get me that common denominator. And then if I multiply this second expression here by x minus 5, I'm going to get the common denominator I need there as well. So our common denominator is going to be x plus 7 times x minus 5. So let's perform our multiplication. So here we're going to distribute the x. So we have x squared minus 3x plus 7x minus 21. Then I have a little plus sign with the same denominator. And here I have x and 8 being distributed. So I have x squared minus 5x plus 8x minus 40. And that's just going to equal what is on the right-hand side currently because it doesn't need any changes since it already has that denominator of x plus 7 times x minus 5. So here, because I have common denominators in every single fraction, I can now essentially ignore them, add the two numerators together, and set them equal to the numerator on the right-hand side of the equation. So I'm going to start adding these together as I go. So here I see I have an x squared and an x squared. So on the left-hand side, I have 2x squared. I then have a couple of different things with x being added. So I know that -3x and 7x become a positive 4x. These two here become a positive 3x. So added together, I have a positive 7x. And then -21 and -40 add together to be -61. And that is equal to 4x minus 10. Now because I have this x squared up here, I know that I again have a quadratic that I need to solve. So I'm going to start by adding 10 to each side and then subtracting the 4x over. So I have 2x squared plus 3x minus 51. Now from here, I need to think through my quadratic solving strategies, and because this one has some larger numbers, I'm going to choose to use the quadratic formula. You can attempt other ones if you would like, but because I didn't notice right off the bat that it's easily factorable, I'm going to use the quadratic formula here. So let's set up our quadratic formula. So we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 2. So now if I simplify what's underneath the root there, so 3 squared minus 4 times 2 times negative 51, I end up with negative 3 plus or minus the square root of 417 all over 4. I then square root 417 and end up with negative 3 plus or minus 20.42 all over 4. And again, I'm okay if you just round for these because for right now we're just trying to get an estimate of what x would be. So here I have the positive version as well as the negative version. And now all I need to do is simplify. So negative 3 plus 20.42, then all divided by 4. So that leaves me with 4.36. Then we have negative 3 minus 20.42, all divided by 4, which is a negative 5.86. So here I have found my two values for x that if I were to take them and put them back into our original equations up here, they would make the original equations true.